Principles of the electrocardiogram. The heart is made up of 4 chambers: the right atrium, the right ventricle, left atrium and left ventricle. The right side of the heart collects blood, where the left side of the heart returns blood back to the body. Cells in the cardiac conduction system can generate impulses which get distributed throughout the heart. Starting with the SA node, which acts as a natural pacemaker to the heart, produces energy that travels to the AV node, which acts as a gatekeeper. The energy travels to the bundle of His, which can be found at the septum of the heart, moving towards the right and left bundle branches, leading towards the Purkinje fibers that are found in the subendocardial surface of the ventricle walls. This network of specialized muscle cells sends signals to the rest of the heart, causing a contraction and the heart to beat. The SA node generates electrical stimulus regularly at 60 to 100 beats per minute, but if the SA node wasn't working properly, the other areas of conduction have their own pacemaker cells. The SA node is located in the upper wall of the right atrium. It sends energy to the AV node, which is located in the Koch triangle. The energy released from the SA node will generate a P wave on the ECG. This represents electrical depolarization. The energy disperses into both left and right atria. Depolarization of the right atrium is responsible for the early part of the P wave, where depolarization of the left atrium is responsible for the middle and terminal portions of the P wave. The presence of a P wave immediately before every QRS complex indicates sinus rhythm. The 2 bundle branches taper out to produce numerous Purkinje fibers, which stimulate individual groups of myocardial cells to contract. The spread of electrical activity through the ventricular myocardium produces the QRS complex. An ECG rarely shows atrial repolarization since it coincides with ventricular depolarization. The T wave reflects the repolarization of the ventricles. ECG 3-lead placement. A 3-lead ECG placement monitors one of 3 leads. It's important to attach the electrode to the bony prominence of each upper limb to prevent tremors, such as the ulnar styloid process, where the same goes with attaching to the bony prominence of each lower limb to prevent tremors, like the medial malleolus. The red lead is attached to the right arm. The yellow lead is attached to the left arm. The green lead is attached to the left leg. And the black lead is attached to the right leg. These leads primarily detect electrical activity in the frontal plane of the heart. Einthoven's triangle explains that cardinal limb leads form an equilateral triangle when deciding the electrical axis of the heart. Lead 1, right arm negative, current goes towards left arm positive. Lead 2, right arm negative, goes towards left leg positive. Lead 3, left arm negative, goes towards left leg positive. The right leg electrode removes artifact from the ECG and is not directly providing a visible trace. Augmented leads: AVR right arm positive leads towards the heart, AVL left arm positive leads towards the heart, and AVF left foot positive leads towards the heart. Precordial lead placement. There are various ways in how to find the location of V1 and V2 electrodes on a patient in different shapes and sizes. To start off with, we can find the angle of Louis, which is located in the second intercostal space. If unable to find the angle of Louis, you can look for the sternal notch and then calculate 3 finger widths down, which leads you to the second intercostal space where the angle of Louis is located. From there, we have to move down 2 more spaces to the 4th intercostal space. That on the right sternal edge is where electrode V1 will go. Electrode V2 will then go opposite on the left sternal edge of the 4th intercostal space. We will then skip V3 and move to V4, which will be mid-clavicular line on the 5th intercostal space. You can do this by finding the sternal notch, go to the clavicle, and then work your way down to the 5th intercostal space. That's where V4 is located. V3 goes on the bony prominence between V2 and V4 in a diagonal shape. Electrode V5 will then go on the anterior axillary line on the same plane as V4. And V6 will go mid-axillary line on the same plane as V4 and V5. Each lead is a view of the electrical activity of the heart from a specific angle across the body. Even though there are only 10 leads, we actually get 12 views. The different views reflect the angles at which electrodes look at the heart and the direction of the heart's electrical depolarization. Subscribe to the channel for more.